Hi everyone. Now let us see a problem with Gauss Jacobi iteration method. If we consider a system of linear equation 2x plus 10y plus z equal to 13, 10x plus y plus z equal to 12, 2x plus 2y plus 10z equal to 14. So first we have to arrange the system in a diagonally dominant form. To solve by Gauss Jacobi iteration method, we have to arrange this system in a diagonally dominant form wherein the first equation will be written in such a way that the coefficient of x is the largest compared to the other two equations, and the coefficient of y is the largest in the second equation compared to the other two equations, and the third equation has the largest coefficient for z compared to the first and the second equation. Having written it in this form, we number the equations as 1, 2 and 3 respectively, and x, y, z values are written from equations 1, 2 and 3 respectively. Now the question is not having the initial approximations, therefore we have to assume the initial approximations x0, y0, z0 as 0, 0, 0. Having assumed it, proceed to find x1, y1 and z1 values. So x1 is 1 by 10 into 12 minus y is now replaced by y0 minus z replaced by z0, and substitute the initial approximation values and solve. That will lead to 12 by 10, which is equal to 1.2. Hence x1 is 1.2. In the same way, y1 is 1 by 10 into 13 minus 2x0 minus z0 minus z0, z replaced by z0. x0, z0 is 0. Therefore, 13 by 10 is what is obtained, which gives us 1.3 for y1. z1 is 1 by 10 into 14 minus 2x0 minus 2y0. That gives us 14 by 10, that is equal to 1.4. Now proceed to find x2, y2, z2. That is, we are going to repeat the iteration process. We are going to use the same formula, except that we are going to find x2, y2, z2 using first approximate values x1, y1, z1. So by solving in that way, x2 is 0.93 when calculated, y2 is 0.92 when calculated, and z2 is equal to 0.90. So we are going to proceed because there is a variation between x1 and x2 values, y1 and y2, z1 and z2 values. Hence, it is concluded that the x, y and z values have not reached the desired accuracy. Therefore, we need to proceed with the iteration process by finding the next approximation, that is x3, y3, z3. Having found x3, y3, z3, we need to compare the values with x2, y2, z2 respectively. So we can see that the values have still not converged. Therefore, proceed to find x4, y4, z4. Now when you compare x3 is 1.018, x4 is 0.9946. So by comparing these two values, we can see that the values are getting closer, but rather they haven't converged. Compare y3 and y4. y3 is 1.024, y4 is 0.9934. Their values are getting closer but not converged. Similarly with z4. Hence proceed with the next iteration, and we see that we'll get x5 as 1.0015, y5 is 1.0020, z5 is 1.0024. So 0.99, round off value of 0.99 is 1. And we can see that the value has converged. Similarly with y4 and y5, z4 and z5 values can also be observed that they have converged. Hence, we conclude that x is approximately equal to 1, y is approximately equal to 1, and z also approximately equal to 1. Substitute these values of x, y, and z in one of the given equations to verify for correctness of values. Thank you.